Now, combining like terms is something that you all have been looking at for quite a while, and you've got a lot of different strategies for figuring this out. So, for example, if you had something that looked like 3x minus 2y minus x minus 3y, one of the strategies that some of you have been using is to underline the terms that are the same and maybe circle other terms that are the same. In other words, you're just identifying things that go together. And so some of you then rewrite this so they have the terms next to each other, right? And then you would just simplify. So you've got 3x minus x is 2x, and you've got a negative 2y minus 3y is negative 5y. And this is something that you've been doing for ages. We've been doing this for months since the beginning of the year. Now, where you're getting confused is seeing it in the context of exponent rules. What you haven't been doing, and this is good, is you have not been changing the exponents on these x's. So in other words, the little exponents that are hanging out here are little ones. Same here, little ones. And when you combine these like terms, rightly, you've not been doing anything to the exponent values on the x and the y. So in other words, when we're combining like terms, we're using the bases of any given exponents to help us determine which terms go together. But that's kind of where it ends. After that, the exponents stay exactly the same. So let's look at another example that would show us that. So another example might be something that looks like a squared plus 3ab minus 4ab plus 3a squared. So again, we're looking at like terms. We see that these two are like, and we also see that this and that is alike. And so then we just rearrange in the same way that we have been. So we've got a squared plus 3a squared, and then we've got 3ab minus 4ab. And so now I've used my exponents and my bases to arrange this such that the like terms are together, and then I just leave the exponents alone. So I've got a squared, and 3a squared becomes 4a squared, and then I've got these other two terms here, which then become a negative 1ab, or just a negative ab. Alright, so now what we might do is name this thing that we've got here, this polynomial that we've got. So first of all, I notice that I have two terms now. So the last name of this thing is going to be binomial. Right? And then what I have to do is I have to look at each of the terms individually to see which of these has the higher degree. So I'm looking at this one. This one has a degree. This one has a degree of 2. There's a 2 on that exponent. And then this one here has a degree, a degree of 1 plus 1, also a 2. So what that makes this is a second degree binomial. Another way that you might see a combining terms problem is something that's written out like this. You might have 2x minus 5y plus 2 plus 5x plus 6y minus 7, right? And so it's just taking, this is just saying I've got this one polynomial and this other polynomial, and I want to combine them with addition. The nice thing about addition is I can just read this across. In other words, I can make it look like the problems that we've had before. just like this. Right? And I can use the same strategies that I was using before, where I underline ones that are the same, I can circle ones that are the same, and I can just like, I don't know, triangle, just keeping looking at different symbols that exist there. And I can rewrite it so that I've got 2x plus 5x minus 5y plus 6y and plus 2 plus, minus 7. And so then from here, I see that I've got 7x, and I've got 1y, and I've got negative 5. So turning this addition problem right here into a combining like terms problem. So now at the very end, I'm going to look here, and I've got 1, 2, 3 terms, so I'm naming this a trinomial. And then I'm going to look at each of the terms individually for the degrees. So this term, I've got x to the first power, so this is just a first degree. And then this term here also is the power of 1, so I've got a first degree. And then this term right here is a constant term, it's got no variable, so in other words, it's got a degree of 0. So the highest degree that I've got out of these two is 1. So we're going to call this whole thing a first degree trinomial. Let's look at this one again. One of the other strategies and the other setup that we've seen is to take everything that's in the first polynomial and write it out. So we've got 2x minus 5y plus 2, and then we'll take everything from the second polynomial and line up the like terms underneath. So we might have, we're going to put this 5x underneath the 2, we're going to put the plus 6y underneath the 5y, and we're going to put this negative 7 under the 2. And so now what we can do is we've already, in one step, we've identified the like terms and we've lined them up. That way we can just add down. So we've got 7x plus y minus 5. So we get the same answer. And what this also allows us to do is see very easily, we can see what we're working with in terms of degree here. So all of this combined together, we've got one term coming out. It's a first degree. And then we've got this other thing that gave us a first degree y, and this other thing here that gave us a constant term. So the highest degree is 1, and we've got 1, 2, 3 terms, so we've got a first degree trinomial. Another type of problem that we might get is a polynomial with subtraction, or subtracted by another polynomial. So what I'm going to do, or what I'm going to suggest to you, is that we've got actually a negative 1 hanging out here. So what I'm going to do is I'm going to distribute that negative 1 into each of these terms, which then is going to change this entire thing into addition. So this whole first polynomial is just going to hang out by itself. And then the second polynomial is changed to a positive y squared, a positive 3y, and a negative 1. In other words, all I've done is taken this subtraction problem and turned it into addition problem. And now I've simply got a combining like terms problem in the same way that I did before. And I can either use the vertical method where I'm aligning each of the terms, or the underline and switch the order, or use the commutative so I can line up all the like terms. I'm going to choose vertical for this one. So I'm going to say, take this first polynomial, line it up. I'm going to take the next polynomial, which looks like this, line it up, and just add them all together now. So I've got 2y squared plus 9y minus 6. So my final polynomial, or the answer to this original subtraction problem is 2y squared minus 9y minus 6. Now if I'm going to name this, I'm going to look at each of the different types of terms here. I've got this monomial, or this term right here, with a power of 2, so this is a second degree. And then I'm looking at this one right here, got a power of 1, so this is just a first degree, and then this one is constant. So when I look at each of these individual terms, I see that this first term has the highest degree, so that's the degree of the entire thing. So I'm going to call this whole thing a second degree, and then I've got 3 terms, so that makes it a trinomial.